All right, so physics. So last video, which was a bit of, when was that, Friday? I'm not even sure now. But in the last video, we were talking about projectiles and their trajectory. And what we said was that you have to treat the horizontal and the vertical separately. But the thing that ties them together is always time, because no matter what, no matter how far it travels horizontally or how far it travels vertically, it's in the air the same amount of time. So time is the thing that joins them. Now, when we talked about questions in the last part, and I haven't really gotten a lot of questions yet, but it's only Sunday, so I kind of expect there might be, because I expect that Sunday night you guys are going to try those questions. If there is, then I'll make a video about that. But for now, those questions all dealt with like a plane is flying and you drop something out of the plane and so it's falling, something like that. Or the example we did, you were standing on a cliff and you threw the rock up, out and down, so it went like that. In those, when you throw it or when you let it go, it's going directly horizontally. You threw it horizontally out. But what if it doesn't take off, or it isn't going straight when it starts? Okay. What if it takes off at an angle and then it lands at an angle? You should be saying that's a parabola. You're right, it is. And so over here when it landed, we had things already landing at an angle, and what we had to do was we had to figure out the y component and we had to figure out the x component to figure out the final velocity, and we had to break it apart into its components and then use Pythagorean theorem. But we didn't have to do that at the beginning, because in the questions we had, it was starting straight horizontally and then headed down. But what if it isn't? What if it's starting down here and going up? Well, notice it's starting at an angle, which means the only added step to this is that you have to break your initial velocity up into an x component and a y component. Now, if it takes off at this height and it lands at that height, the same height, then that's going to be a perfectly symmetrical parabola. And we're going to talk, there's some special formulas for that. And we're going to talk about those. And you don't have to use the special formulas, but they tend to be easier because it's just a matter of sticking numbers into formulas. But that tends to be a little bit easier if it is asymmetrical. In other words, the height it takes off from is the same height it lands at. But what if it is not a symmetrical parabola? For example, the question on page 539, Wicket, the question on page 539 basically says you have a golfer and he's here. Okay, you have a golfer, he's here, and he hits the golf ball, but the green is actually up here. That's where the green is. So when he hits the ball, that's not a symmetrical parabola, right? You've got the up part, but it's only coming down part way. So what do I do if that's the case? So let's look at that question. And again, it's on page 539. Is where I am. So a golfer hits the ball off the tee, giving it an initial velocity of 32.6 meters per second at an angle of 65 degrees with the horizontal. So when he hits it, that angle is 65 degrees. It's the four-wheeler, relax. So he hits it at an angle of 65 degrees with the horizontal. The green, where the golf ball lands, is 6.3 meters higher. So 6.3 meters higher. So the difference in height between here and here is 6.3 meters. Now that is a height. I could also call it a y displacement because it's how much the height is going to change vertically. The other word for that is also, no, it's not the range. The range is across, okay? So displacement in the y direction. The question is, figure out the time interval that the ball is in the air. So how long is the ball in the air for? Now it makes sense that that's the first thing we're going to find, again, because time is what connects everything. The horizontal distance that it travels, so dx. So we know it's going to go up 6.3, but how far across is it going to go? So we want, also called our range, right? So we want the x displacement. And finally, the velocity of the ball just before it hits the ground. So I want a final velocity. Again, they're not asking for a speed, they're asking for a velocity, which means you need a direction, you need an angle that it's coming in at, all right? So again, earlier I said the difference when it takes off at an angle is that you're going to need to figure out the components. So it's going 32.6 meters per second, but that's at an angle. So of that 32.6 meters per second, what is the horizontal velocity? How quickly is it going across? And what is the vertical velocity? How quickly is it going up and down? So I'm going to need to figure out the initial velocity in the x direction. I'm also going to need to figure out the initial velocity in the y direction. All right, so the x is the adjacent side. So you're talking cos, so it's going to be 32.6 times cos of 65 if you do the math that goes with that. And that turns out to be 13.78. So the initial velocity is 13.78 meters per second. That's in the horizontal direction. Now remember, the horizontal velocity never changes. Sorry, there was a spider above me and now it's disappeared, which is freaking me out just a little bit. Where did it go? Oh, it's way over there now. Okay, I found it. Phew. I don't want it attacking me. So remember that horizontal velocity remains constant. There's no force horizontally of any kind. So there's nothing to slow it down because we're neglecting air friction. There's nothing to slow it down horizontally. There's nothing to change its velocity horizontally because there's no force acting on it horizontally. Vertically, that's our y direction, so that's sine. So it's going to be 32.6 sine of 65. And when you work that out, it works out to be 29.55. Now vertically, there is a force acting on the ball. Vertically, there's gravity working on the ball. So vertically, the velocity is going to change. It's going to slow down as it goes up, and it's going to increase as it goes down, right? The velocity is going to be constantly changing. All right. So the first thing we want to figure out is time. So we know that there's a formula that says displacement is equal to initial velocity times time plus 1/2 AT squared, We used these in the last question. The only thing was, if I was throwing something horizontally, that meant initially my vertical velocity was 0. So I would automatically put 0 in here for my initial velocity. That is not the case now, okay? So remember, we are talking about the y direction here, because I don't know horizontally how far it's going to go, but I do know vertically it's going to go 6.3 meters, right? Because the difference is 6.3 meters. So my displacement is 6.3. My initial velocity is 29.55 t plus 1/2 times acceleration, which is 9.81, times t squared. Now, it is important in this case, it's going to be important. 9.81 is working what way? I hope you're saying down. 9.81 is acceleration due to gravity. It is pulling down on the ball. So that should be negative, and it's important that it is. So we have 6.3 is equal to 29.55 t minus 4.905. That's just 1/2 times negative 9.81 t squared. Now, if I move everything over to one side, I have 4.905 t squared minus 29.55 t plus 6.3 is equal to 0. Now remember, we're trying to solve for t. This is a quadratic equation, t squared, t, and no t, constant. So that means my A is 4.905, my B is 29.55, negative, and my C is 6.3. So I'm going to do that negative b plus or minus the square root of b squared minus 4ac all over 2a using those numbers. What you find is you get 0.2213 or 5.803. All right, now that's two answers, but only one of them is correct. Only one of them is correct. All right, remember, this is a time. Well, the ball is going to reach a height of 6.3 meters 2 times. It's going to reach it here, but it's also going to reach it here. See, same height. So the first time is actually the first time the ball reaches 6.3. Then the ball continues going up, then it heads back down and lands here at 6.3. So 5.83 is actually 803 is actually the right answer, because this one is the first time, but it hasn't reached the hole yet at that point. So my time is 5.803 seconds. Paying attention to significant figures, looks like 5.80. Next. So I figured out the time. I'm going to leave those up there for a minute. Figured out the time. Now the next thing it wants to know is the displacement horizontally. What is the distance horizontally that it goes? So we know vertically it ends up 6.3 meters from where it was, but horizontally, how far does it go? Remember that horizontally velocity is constant. It does not change, which means we can use the formula velocity is displacement divided by time. And my velocity is 13.78. And now I know a time, it's 5.803. I can figure out a displacement. My displacement, I'll put a little x there so that you know I'm doing x. My displacement in the x direction is 79.965. So paying attention to significant figures, that is 80 meters, or 8.0 times 10 to the first. So vertically, it's going to go 6.3 meters, but the hole is actually 80 meters away. If you play golf, you know that even though we are a metric society, supposedly, usually they give hole lengths in yardage. But anyway. All right, the last thing we have to figure out is the final velocity. Now remember, this is hitting at an angle, so I'm looking for the final velocity. So I need to figure out an x component for velocity and a y component for velocity so that I can use the Pythagorean theorem to figure out the velocity. Again, for the x, it doesn't change. Velocity doesn't change. So this is, even though that's an initial velocity, technically it's just a velocity because it doesn't change. So 13.78 is here. What I don't have, because remember vertically the velocity is changing, I know what the initial velocity is, but I don't know what the final velocity is. But there's a formula for that, and it says final velocity is equal to initial velocity plus acceleration times time. And again, I can add in here, I'm looking specifically right now at the y direction. So I'm looking for the final velocity. The initial velocity is 29.55. Acceleration, remember that acceleration is down. So I'm actually going to have to put negative 9.81 times time, which is 5.083. If I do that, it turns out that it is negative 27.38. Remember negative because it's headed down. The ball's going down. That's why it worked out to be negative. So that is my final velocity in the y direction. So that would go here. So if I want to know my final velocity overall, final velocity squared would be equal to 13.78 squared plus negative 27.38 squared. And then I would just take the square root of both sides, and I would get that my final velocity is 30.65, which is 31 meters per second. But again, if they ask for velocity, you also need a direction. So tan theta is y over x. Don't worry about the positive or negative when it comes to doing this. Just do that the y is 27.38 over 13.78. Do shift tan, wicket, stop. It works out to be 63 degrees, and that would be 63 degrees with the horizontal. So 63 degrees right there is where it would be. All right, so that's how you do one of those questions. We're going to leave it at that. I'll give you some to practice. If you did not get some of the ones in the previous part, please let me know so that I can make a video about that if I need to. Hopefully it all went well, but if it didn't, just let me know. All right? Thanks.